Thank you for the kind introduction. I'm going to share my screen here. I have some slides, but hold on. Here we go. Yes. So once again, I'm Dan Strano. I'm technical staff member at the Unitary Fund. We, by mission statement, are a nonprofit helping create a quantum technology ecosystem faster, better, and to benefit everyone. And welcome back again to the Quantum Game Jam. Today, I want to talk to you about opportunities to get further deeply involved in the quantum open source community, and maybe even opportunities for funding. But here on this slide of team members of the Unitary Fund, you'll see me in the upper right-hand corner. And I want to impress upon people that you might notice that I don't have the appellation PhD attached to my name. And the way I got involved in the quantum open source community was basically just by building software alone in my room for the most part. There's a backstory behind this, but my crack simulator framework I developed for about 3 or 4 years before joining the Unitary Fund. And hobbyists, there is a place for hobbyists in the community. One doesn't necessarily have to have a doctorate in physics or computer science to get involved in the quantum open source community. For example, if you have an idea for a project that might be attendant to the quantum open source software community, we offer micro grants. Current round of funding is $4,000. Materials are meant to take a minimum of effort to fill out, about 7 minutes. The whole commitment is a midpoint check-in and an end of project check-in at say 6-month mark in a year, or 3 months and 6 months, depending on the timeline of the project. I was a recipient for my crack simulator framework before joining the Unitary Fund. My teammate Vincent Russo, who is the other developer on Metric, was a recipient for Taquito. And this is a great opportunity if you have an idea for a project that otherwise might not receive attention or funding. Please apply. It could be art, it could be science, it could be software, but it could be a game. Always an opportunity, and please apply. But for an overview of Unitary Fund's program, once again, we are a 501c3 nonprofit, helping create a quantum technology ecosystem that benefits the most people. We work with QTIP, which is for quantum simulation and simulation of quantum computing circuits and devices. Nathan Shama, our CTO, was a maintainer of QTIP for a number of years. We also run Unitary Hack for the past couple of years and plan for the next year. If you want to get involved in a hackathon after the game jam in the quantum open source community, but timing for that will probably be around May or June in 2023, and you could get paid for closing issues on quantum open source projects. We also have weekly community calls for various projects like MITIC, QIR Alliance, which is Quantum Intermediate Representation, and QTIP, and anyone can join that. There's a standing invitation to our Discord server at discord.unitary.fund on the web. So please follow the invitation and join the server. All are welcome. If you want to ask questions about software development or help set priorities, that's what these community calls are there for. We also are currently doing a quantum open source survey, which is meant to take about 8 minutes. Here are the links really quickly. And if anyone already has experience in quantum development, we'd love to hear more about your experience, the software and technology you use, but also there's a second separate optional component, which is on diversity and inclusion, which we also appreciate if you fill out. But now I want to talk a bit about the products offered by the Unitary Fund. These are all open source and free. MITIC is under the GPL, but MITIC by tagline is a Python toolkit for implementing error mitigation techniques on quantum computers. So what's the difference between error mitigation per se and error correction? So standard error correction encodes a logical qubits in many physical qubits, maybe 5 physical qubits make up a logical qubit, for example. And we make intermediate measurements for syndrome detections. So say we measure a 0 on the last qubit, we might know that means no error. Whereas if we measure a 1, we know that that means a particular type of error. We know that we need to perform certain gates to correct the error, and we fully corrected the error at this point. And that's a scalable technique, but it's unfeasible with near-term quantum computers because basically they have too few qubits, and they're not necessarily they have too much noise to pass a threshold for error correction to work. Error mitigation, on the other hand, we perform multiple and different noisy quantum computations. Like you enter a circuit in Qiskit, for example, we might insert additional gates that add up to identity. They have no effect on the circuit, but they increase the noise level, and we could extrapolate to the point of zero noise. That's basically a technique called zero noise extrapolation. We collect those results, we infer the ideal expectation values from noisy data, and this is asymptotically unscalable in that the number of samples we have to collect and the additional the classical post-processing doesn't scale to hundreds of qubits, but it's feasible with near-term quantum computers. So we can do this now. And this is basically the function of METIC. We also have community-driven quantum benchmarks at metric.info, which I'm going to switch over to right here. But if you want to browse state-of-the-art in quantum benchmarks, come to metric.info. You can add your own results as well from simulators or cloud hardware services, and Metric is also fully open source under the Apache 2.0 if you want to use the code of the app. And finally, I want to talk about excuse me, my simulator framework, which is Crack and PyCrack. By Tagline, an open source comprehensive GPU accelerated framework for developing virtual quantum processors. In other words, a simulator, but it's already fully integrated here in Unity, if you can see my screen. But here's Crack actually running in open relativity, a fork of open relativity that I started and have maintained for years since and continue to update. But in addition to collision and reflection and some nice goodies I made in the relativity treatment, these boxes over here, notice the point of light transitioning between these two boxes. They're performing the quantum teleportation algorithm. And the orientation of the box shows you the state of the qubit as they perform the algorithm. And this is done with the Crack framework already fully integrated, wrapped for C# and Unity. The box in the middle is doing a triplet oxygen simulation, which is harder to visualize, but connected to the notion of space and time in the space. So here are some goodies. You're free to use these. This is under the MIT license, and I wanted to share this with you and some of what the Unitary Fund is doing. So remember, as a hobbyist, you can get involved. You can get funding. That's basically it for me. That's my talk. But thank you.